Jonathan, literally hit the nail on the head with the reclaimed lumber market today, right? It's niche wood, super high quality, really old materials, and it's all done with labor. And everybody we talk to, the labor will do it for a couple months, and then they run away screaming. You've literally got to put them on another project, right? It is just so tedious, so hard work, and just mind-numbing work that nobody wants to do it. So even for that high stuff, you have an employee problem. So you're right there, Jeff. We're not taking anybody's jobs. We're actually creating jobs with a robot. Because instead of this material heading through, $1.5 million grinder and becoming mulch or landfill material, what we're doing is the folks and the machines are literally pulling the nails, the staples, and the screws out. And so what we've done is those brushes that Jonathan was talking about are actually cleaning the surface of the material to make sure that we can see the nails. We're shining them up a little bit, which helps with our computer vision. Gets rid of any dirt, any grime that's built up on that lumber over the years. And then we're taking it after the brushes and we're using cameras to take pictures of it. And so those cameras are creating a 3D point cloud of that board. And in there, our AI goes in and identifies all the metal contaminants that are in it, builds a path algorithm for the robots, and then sends those end effectors after it. And literally, those end effectors are, their inspiration from the pry bars and the claws that everybody's used, right? And so we built our own gantries. So if you can envision, like a semiconductor fab plant, but instead of semiconductors, it's wood, and we're disassembling it, right? We're pulling all these metal components out. We have to do it very quickly, right, to make the economics work. So it's high-speed gantry systems, just ripping metal out as quick as it can. And then at the end, we got a metal detector to make sure we got it. So I've got like old school technology, right? Metal detectors have been around for infinity, making sure I got it right. Yep. Then I've got the latest and greatest computer vision and AI algorithms crunching away at these robotic end effectors that we've developed using some of the latest and greatest hardware tech.
Oh. All right. So now we know how it happens. What got you to do this? Where's the inspiration come from? Like, well, it's obviously reclaimed wood, and this has been around for a while, and the problem's been around. What sparked it?
Yeah, so when I was at my last project, I built the innovation program. We brought robots into construction. We were changing how the built environment works, addressing the craft problem. And so typically what we did is we looked at for robotic solutions, it had to be a big problem, had to be highly repetitive to justify the capital cost of bringing the robots in, right? There's some standard check boxes that every problem has to solve before you bring in the robots. Mm-hmm. And so when I got involved with the company's sustainability program, we're evaluating waste streams coming off of our job sites. And concrete and steel both have recycle paths or down cycle paths, but they're not heading to a landfill, right? Which is better. But all the wood and the plastics and partitions and all this material is all going to landfill. I'm like, why is this beautiful lumber going to landfill? And we had this mass timber group that's going out and harvesting, large volumes of trees and turning them into wood buildings. It's like, wait a minute. So we're burying all this beautiful material in a landfill to go cut down all these forests to build these buildings. There's a disconnect here. And so from that research, everybody's like, it's the metal. You got to get the metal out. And so it's a massive problem. 37 million tons of dimensional lumber every year here in the US. That's equal to about half of the softwood we harvest from our forests. So every year we harvest all these forests and we essentially throw it into a landfill. That's what's coming out of our built environment today. And it's like, there's got to be a better way. Those are massive numbers, massive market opportunity. And then you get to apply cutting edge tech to solve it. If I tried solving this problem, 10, 15 years ago, it wouldn't have happened. The tech just was not there. Despite my opinion of the self-driving cars, I have to actually thank them for driving down the computer vision tech and costs, right? The cameras and the LiDAR and all their sensing technology, they have seriously commoditized that to the point where my engineers are just like, they can buy it on Amazon, right? It's just like so available on the hardware side. And so we've reached that inflection point where the costs have come down, the capabilities have increased. It's a massive problem that has to be solved. And it's not one we can throw labor at it, right? I can't go out and hire 200 laborers to go clean up lumber. The economics just will never pay off. This is one that has to be solved with technology. And so when I got to combine, my passion for construction and technology and sustainability together, my wife's like, oh, frick, here he goes again, right?